Hello, this is Tamir Galili, exam chapter 25. My date of birth is January 5th, so January, question number 1. Let's get started. Alright, question number 1 has 4 parts. Part A. The drift velocity is the component of a current carrier's velocity due to acceleration from the electric field in the conductor. This corresponds to the average speed of all of the current carriers in the conductor. The current carriers also have a random thermal motions, but the randomness causes the velocity due to thermal motion to cancel when averaged over a large number of current carrier. If the electric field inside the conductor has a magnitude of E, and the charge Q is accelerated from rest from time tau, what is the final velocity of the charge? Alright, so we know that due to Lorentz law, it indicates that a force consists of magnetic force and electric force. So we know that let me use a different color pen so we can tell the difference here. We know that F is equal to Q times E, where Q is the electric charge and E is the electric field. We also know we can compare it also to Newton's second law, which indicates that F equals mass times acceleration. All right, we know that the acceleration is velocity divided by time. All right, so now we can compare the two and see that V, we know that V is equals to mass, Q times E equals mass times velocity divided by time. All right, and now we can equate everything. Velocity equals Q times E divided by M times T or tau, and that is our answer for part 1. All right, let's get started with part B. All right, the magnitude of the drift velocity is very small compared to the speed of random electron motion in the metal. This means that between collisions, the mean time between collision can be calculated from the mean free path d, which is the average distance that an electron can travel before colliding with one metal nuclei. Using these variables, what is the mean time collision tau? Let E of F be the free energy of the electrons. All right, we know that velocity is distance divided by time, so we know that distance equals velocity divided by time, and we all velocity times time. I apologize. All right, we also know that the energy of an electron is 1/2 mv squared. All right, and then we can calculate V being 2e sub f over m, the square root. All right, so now d equals V times t. All right, we do d equals V is the square root of 2 times e sub f divided by m times t. All right, and in order to figure out what t is, you do d divide by the square root of 2ef over m, which is the square root of m over 2 E sub F. All right. We're finally getting to part C of this question, of this problem. We recall that the conductivity sigma of a substance is defined as the relation of J equals sigma times E. And the resistivity rho is the inverse of the conductivity, which equals rho, which is rho equals 1 over sigma. Given the expression for rho in terms of microscopic properties of a metal, use QE for the for the charge of an electron on an electron. So, current density equation is measured in amp per meter squared, so we know that also J equals sigma times E. All right. We also have the equation of the current density of Q E times V. When N is the free electron density, QE is the charge of the electron, and V is the speed of the charge. All right. So from the first equation, right over here, we can tell that V equals Q times E times T over M. All right. So we know that this is equal to NQE times QE times E times tau divided by M from the equation from part A. All right, which is also equal to N QE squared tau divided by the mass times the electron. If so now we can also equate both equations here and see that sigma is equal to NQE squared times tau over M. All right. And now the resistivity of rho is equals to 1 over sigma. All right. 1 over sigma. We're just going to flip it around, which is equal to M over NQE squared times tau. All right. We know that V equals D divided by T, and then we know that T or tau is equal to the distance divided by the velocity. All right. Now we're going to plug in T in the rho equation, or the resistivity equation. We have rho equals M times V over N QE squared times the distance. All right. We're going to get the properties of V, right, from part B, which is equals to 2EF divided by M, or the square root of 2EF divided by M, which equals to 2 times, or it equals M times 2EF divided by M divided by NQE squared times D. All right, which we can simplify that to rho equals square root of 2M times E sub F divided by N QE squared times D. All right. which we know that m is the mass, EF is the Fermi energy, and N is equal to the free electron density. QE is the charge of the electron, and lastly, D is the free path, or the mean, or the distance. All right, therefore, we're gonna go to part D, which is basically gonna put all those answers together. We have rho equals, we're just gonna get the answer from our last problem, all right, which is the square root of 2 times the mass times E sub F over NQE squared times the distance. All right, and all we have to do now to find the resistivity is plug in all those numbers, which is equal to the square root of 2 times m is the mass. The mass is 9.11 times 10 negative 31 kilograms, times EF is 8.86 times 10 to the negative 19 joules. That is going to be all divided by 5.90 times 10 to the 28, and then we're going to multiply that by negative 1.60 times 10 to the negative 19 coulombs squared, and that is finally all going to be divided by 3.45 times 10 to the negative 8 meters. And then all we have to do is just plug it in into our calculator. The square root of 2 times 9.11 times 10 to the negative 31 times 8.86 times 10 to the negative 19, and that is all going to be divided by 5.90 times 10 to the 28 times negative 1.60 times 10 to the negative 19 squared times 3.45 times 10 to the negative times 10 to the negative 8, which would equal to 2.44 times 10 to the negative 8, and that would be in ohms times meters. Thank you guys so much, and I'm excited to see you next time.